All right, guys, welcome to this page of the notes, and here's what we're going to do. We're going to start on that second objective, which is solving rational inequalities. And as you can see from what I've got written here, it's going to be slightly more complicated than solving rational equations, but I'll just quickly run through the 4 steps. They'll make way more sense as you begin to see example problems, but we'll talk about them here first real quick. First thing we're going to do is state the excluded values. We've seen this before in previous sections. Stating the excluded values simply means figure out what gives you division by 0, and then we'll exclude those values. All right, so we do that by setting the denominators equal to 0 and solving for the variable. That'll let me know what the denominator cannot be. We'll exclude those values. Then we're going to solve the related equation. This is interesting too. We've seen this before when graphing inequalities, where instead of graphing the inequality, we graph the related equation, and then we take a look at the inequality to figure out where to shade. We're going to do something very similar here. We're going to ignore the inequality and solve the related equation, which is what we just got done doing on the previous pages. Now, once we find the excluded values, and once we've solved the related rational equation, we'll then take those values from step 1 and step 2, and we're going to split a number line into intervals using those values. All right, so let's say I get a value from this guy, I get 2 values from these guys, right? I'll drop those values from part 1 and part 2 onto a number line. I'll split my number line up into intervals. Then what we're going to do is we're just going to test, right? You just got to pick a value in each of those intervals, plug it into the original equation, into the original problem, and check to see if it's true or false. If it's true, then that interval is part of your domain. If it's false, then that interval is not part of your domain. And again, I apologize, I know just kind of like word vomited on you there, but it'll make a lot more sense when we do a couple of example problems. So let's jump into a problem. I'll kind of remind you of the steps as we go through it. So here we go. All right, so this is the first one I want to do with you guys. We're going to solve this rational inequality. And again, like I said above, step number 1, find the excluded values. So step 1. Now remember, the excluded values are what gives you division by 0. So the way that we did this was we took our denominator that has a variable in it, in this case the x minus 2, set it equal to 0. So we have x minus 2 equals 0, which means x is equal to 2. But what does that tell me? Well, that tells me if I plug in a 2, 2 minus 2 is 0. That gives me division by 0, which I know is not allowed. So actually, we have found our excluded value. X cannot equal 2, right? If x were equal to 2, I would get division by 0, and that's no bueno. So there we go. I've got my excluded value, part 1, for solving this problem. Step number 2. Well, step number 2 is to solve the related equation, which means ignore the inequality, just drop an equal sign in there. So I'm going to have x over 3 minus 1 over x minus 2 is equal to x plus 1 over 4. Well, we just got done doing a ton of these on the previous pages here in this note set. You know that you need to find the LCM, multiply everybody by the LCM, and then see what happens, right? Your denominators should go away, the fractions should go away, solve for the variable, and so let's go ahead and jump into this. I need to find the factors of all of my denominators, which is pretty easy. 3 is just going to factor into a 3, it's prime. 4 will factor into a 2 squared, and x minus 2 will factor, well, in x minus 2, which means that my LCM is then each of those factors, the greatest number of times it appears. So 3, 2 squared, and x minus 2. It's everybody. So 3 times a 2 squared, which of course is a 4, times x minus 2. So I wind up with 12. X minus 2. So my LCM is 12 times the quantity x minus 2. We'll multiply everybody by that LCM. Hopefully what it'll do is make all those fractions go away. Let's see. All right. So I'm going to wind up then with 12 x minus 2 times x over 3. Okay. I'll just do it while I go. 3 cancels, reduces the 12 to a 4. All right. Minus. It'll be 12 times x minus 2 multiplied by 1 over x minus 2. I'll go ahead and take care of that now. The x minus 2's will drop out. All going to be equal to x plus 1 over 4 multiplied by 12 times x minus 2. And again, that 4 will cancel the 12 and reduce it to a 3. All right, here's what I've got left then. I have a 4 times x, which of course is 4x, times the quantity x minus 2. So we have 4x times x minus 2. The x minus 2 is canceled. I have a negative 12 times 1, which is just a minus 12. All equal to, and then this one's a little bit trickier here. I've got that 3, the 3 left over, and then I've got this x plus 1 and x minus 2. So here's what's interesting with that. 3 times x plus 1 times x minus 2. What's going to wind up happening here is I'll distribute the 4x. That's awesome. But over here on this side, guys, there's no way to avoid it. You'll need to FOIL those binomials. So we'll have to FOIL these guys. And then after I've FOILed those binomials, I'll have to distribute the 3. All right, so here we go. It's algebra 2. You guys know, you should expect this stuff. You know it's coming. So here we go. That's going to give me a 4x squared, right? 4x times x, 4x squared. That's going to give me a minus 8. And then I got that negative 12. All right, that wasn't so bad. On this side, I got the 3. I need to FOIL these guys first. X times x is going to be an x squared. Stick with me here. We'll do it all at once. X times a negative 2 is a minus 2x. But 1 times x is a positive x. So I have negative 2x plus x minus x. And then plus 1 minus, so I got a minus 2. All right, we'll distribute that 3 through the parentheses. 4x squared minus 8x minus 12 is equal to 3x squared minus 3x minus 6. Okay, here we go. I need to combine like terms. I'm just going to go ahead and move everybody on this side over. So that's going to give me a 4x squared. I'll subtract, so minus 3x squared. I have the negative 8x. I'll add 3x. I have the minus 12, and I'm going to add 6. That leaves me with a 0 over here on this side, right? I've taken all these guys and moved them over to this side, so I'm just left with a 0 over there. We'll combine like terms, and let's see what happens. 4x squared, so that's going to leave me with an x squared. Minus 8x plus 3x, so how about a minus 5x? A negative 12 and a plus 6, so that should be a minus 6. That's all equal to 0. Okay, guys, we've seen this before. What I wind up with is something that is quadratic with any luck. It'll factor nicely into 2 binomials. I don't know, let's find out. The easy bit, x and x, because x times x gets me an x squared. Maybe slightly trickier, I don't know, let's find out. I need 2 numbers that multiply to a negative 6, sum to a negative 5. Actually, that's not bad. How about a negative 6 and a plus 1? That should do it. Negative 6 and a plus 1 should do it. 0 product property lets me split that up. So I get x minus 6 is equal to 0, which means x is equal to 6. And x plus 1 is equal to 0, which means x is equal to a negative 1. All right, guys, let me get these values for you. Here's what I've got. I've got x equals 6. X equals 6. X equals negative 1. But don't forget, up here in step number 1, there it is, I also got this one. X cannot be 2. So I have negative 1, 2, and 6. Step number 3 was to put those values on a number line, to divide that number line into intervals, and then we'll go from there. So here we go. Let me come back down here. Step number 3. Here we go. So step number 3. All right, so we're going to take that number line. There it is. There's my number line. Remember, the values are right, negative 1, the 2 from above, and 6. All right, so I got to get those here on my number line. Let's do this. There's 0, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, and that's plenty far enough. All right, negative 1 was one of the values that I found in step number 2. 6 was one of the values I found in step number 2, and x cannot be 2, which was the value I found in step number 1. So please notice what this has done. This has split my number line into intervals. I have the interval from -1 to -infinity. I have this interval right here from -1 to 2. I have this interval right here from 2 to 6. And I have this interval over here from 6 to positive infinity. I have 4 different intervals. In fact, if you want to, you could go ahead and just drop a dotted line down through there. Right, so that you can see I've got this interval here, that one, and that interval up there. I need to check each of those intervals. I gotta check them all. The way that I do that is just pick a value inside that interval. So I need something less than -1, we'll go with -2. I need something between -1 and 2, we'll go with 0. I need something between 2 and 6. Doesn't really matter what you pick, I don't know, maybe 4 or something like that. We'll see what we go with. Then I need something greater than 6. Let's see, what did I did x equals -2. What you're going to do is you're going to take that -2, you're going to plug it back into the original problem with the inequality, right? Keep the inequality, because what you're checking to see is, does it give you a true or a false statement? You plug that -2 into the original inequality, not the equation, the original inequality. Let me remind you of what it was. It was x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. And here's what you're going to find. If you plug a -2 in for x, a -2 in for x, a -2 in for x, please feel free to use your calculator. Drop that guy into a calculator. What you're going to get is a true statement. This side will come out to be less than this side. So this is true, which means all of these guys are part of my inequalities domain. So open circle on 1, and it's everybody headed in that direction. All right, my next one, I believe I did, because 0 is easy to do math with, so I'm going to use x equals 0. Again, same thing. Plug a 0 in for x, a 0 in for x, a 0 in for x. If you do that, what's going to happen is this side turns out to be bigger than this side, which means the inequality is not, this side has to be less than this side, but you wind up with a bigger number over here than over here, which is not true. This turns out to be a false. No, sorry, let me do it in red. Turns out to be a false statement. So all of these values inside this interval are excluded. They're not part of the domain. All right, let's pick something else. I went with x equals 4. Okay, just drop it in there. Feel free to use a calculator. Plug in a 4, plug in a 4, plug in a 4. Go ahead, figure out what it is, and it does. This winds up being a number less than this guy. So it does. It is true. And so everybody in here is part of my domain from 2 to 6. Of course, 2 and 6 are not included. And then that leaves me with one more. I believe I did x equal to 8 is the one I chose. You'll go ahead and drop an 8 in here, drop an 8 in there, drop an 8 in there. Use your calculator if you need to go ahead and calculate this value, find this value, and what you're going to find is, no, it's not true. You don't get a true statement. You wind up with something that's false. This side is bigger than this side, but the inequality says it should be less than. So, of course, we wind up with a false statement. Sorry, that true should have been in green. T-R-U-E, true. So those are not part of my domain, and so this is exactly what we wind up with then. My solution region, according to, or my domain for this inequality is, you've seen this from the previous section, it is negative infinity, right? Negative infinity all the way up to -1, not included, so we use a parenthesis. Union, right? Union, 2, but not included, so parenthesis, all the way up to 6. But not included, close parenthesis. And that's it, that's my domain. You can choose any value of x you want to as long as it's less than -1, and pick any value of x you want to as long as it's between 2 and 6, but not 2 or 6, and it will be a solution to that inequality. All right, guys, I know they're kind of complicated, they're a little long. We'll definitely do a couple more together on the next page of the notes, but you follow those 4 steps. Exclude the values, solve the related equation, split up a number line, pick some test points to try, figure out what's true, what's false to get your domain. Head on over to the next page of the notes. We'll look at a couple more of these together. I'll meet you guys there.